start this little talk on blockchain and how in Ericsson we introduced blockchain, and then I will slowly, gradually move to how Ericsson in general has been using blockchain and moving to Metaverse to some extent, okay? So my name is Giovanni Francese. I work for Ericsson. Now, I wonder who knows Ericsson. Okay, doing what? Phones, yeah. Sorry for that. This is how Ericsson is known, for phones, but that was an old experience. Maybe you refer to Sony Ericsson. We had quite good phones in the past, but it was never actually our core business. The core business of Ericsson, which you know, it's a Swedish company, but a global company, we make network equipments. So every time you call your mom, your fiancé, your friends, or you surf internet, be aware you are using, most likely, the 60% of probability you are using Ericsson network behind the operator, whatever it is, Vodafone or whatever, right? So this is what we do, network equipments. This is our core business, okay? That having said, so let me talk of how we introduced blockchain within Ericsson, which is a big corporate, I have to say. We are 100,000 people spread globally, and we make kind of $24 billion of revenues on an annual basis. So it's a big company. And like all the big companies, introducing innovation is extremely hard. Extremely. Maybe even harder for Ericsson, because this is a company of 150 years of history. So it's the only company with such tradition in telco. And telco is very fragmented, not very fragmented market in the sense vendors of network equipment globally, we are basically 3, right? So it's extremely complex to introduce blockchain within such big enterprises. And the reason is because there are stratification of IT infrastructure built along the time. And when you want to introduce a new technology like blockchain, it's very tricky because you have to remove many rock on your road, not only specific to technology, but you have also challenges in terms of politics in big companies, right? I don't know if you are very familiar with analyst reports like McKinsey or Deloitte, KPMG or others. On blockchain, they all say for the big companies, for the big enterprises, at this moment, only few they are able to provide blockchain solutions. And today I will show you what we are doing. Most of the big enterprises are still in the proof of concept phase. And the reason is what I said before, it's much easier you find a blockchain solution in small companies because you don't have to compromise with anyone, right? You have your brilliant idea, you're an engineer or a technical guy, and you can spin up your blockchain. I guess you guys, if you are familiar with IT stuff, it's not super difficult to spin up a blockchain solution nowadays. For big corporates, it is. For the reason I said before, because at the end, you need to place your solution in an existing environment, right? So let me show you the problems that we solve by using blockchain technology. So maybe it will be for you some sort of inspiration for similar use case. Not sure if you are familiar with the concept of enterprise resource planning. those are solutions like the main vendors are SAP, or Oracle. Those were born in the 90s in order to establish a integration layer between many organizations belonging to the same company, right? So you have, for instance, HR, or you have the inventory organization, or the supply chain. In a big corporates, there are many of those organizations. In the 90s, before ERP systems like SAP, those organizations, they were running in silos. That means no integration. And if you have to implement a business flow, digital business flow, you need to have some sort of integration. And the ERP were the very first kind of systems providing such a kind of integration. You can see ERP as a common database. And if you have a common database, then you can share data. But please note, this is within the same company. Okay, this is within the same company. But by doing this in the 90s, and those ERPs, they still exist. All the big enterprises, they use ERPs. We in Ericsson, we use ERPs. Everybody uses ERPs. The big problem of this nowadays is you cannot create digital flows between companies by using ERPs, because those are proprietary solutions. So if you have SAP, either you have to convince the other companies using same ERP, or you cannot make it. Okay. So all the companies, they run their business in silos, but we make business together, right? Involving, we talked of supply chain. In supply chain, you have so many parties involved. How do you connect all of them, right? And not sure if you are also familiar with the 2 or 3 tier architecture. So the 2 or 3 tier architecture is basically this one, where you have many parties involved in a business process. So think about supply chain, right? Why today, if you don't use blockchain, there isn't any digital solution providing supply and bringing all the parties together. It's basically because we rely to this architecture, which is called the 2 or 3 tier architecture. What does it mean? A first tier is the front end of the application. So when you interact with an application, you have the UI, right? So this is the front end. Then you have the backend, which usually is a database where all the data resides. And sometimes, not always, you have a third component, which is in the middle between the front end and the backend, translating data or bringing other data and manipulating a little bit to facilitate the communication between the backend and the front end. Why this model doesn't work, which is the most used so far, unless you use blockchain. But this model doesn't work because in order to bring all the parties together, and again, think about supply chain, if you apply this model, someone has to host the data. And the ones hosting the data are the ones that theoretically they can manipulate data. And why someone here, part 1, 2, or 3, they should trust of party 4? That's why this model, it doesn't work. This is the reason why we don't have so many digital flows between the parties. It's a matter of trust or lack of trust between the parties. And this is where blockchain brings value on bringing all the parties together. Because blockchain, as we know, and now you are the class, I play the professor teacher. Sorry, I replace you for a while, teacher. And so, blockchain is, first of all, a distributed architecture. It means we are almost kind of equal in the architecture, right? So there are no privileges in blockchain. It's peer-to-peer, so there is no man in the middle, which potentially can manipulate data. And we don't use exactly a database. Yes, as a very first simplification, you can see the database of blockchain is called ledger, right? But ledger applies another model than the ordinary database. The ordinary database, they apply the so-called CRUD model: create, read, update, and delete. This is called the CRUD model. Basically, you take a table, you can do whatever you want, as long as you have the privilege. So if you are the administrator, you can do whatever you want. In blockchain, you cannot do that. You use ledger, and one of the main big characteristics and capability of blockchain is the immutability of the data. Immutability means nobody, for whatever reason, can change the data into the ledger. And this is a big thing. It's a big thing because the immutability means integrity of data. So the data that someone places in the ledger, for sure, is that one and nobody can cheat or change. We talked about the transparency, because the ledger, we said in a distributed architecture, the ledger is available to all the parties. So this is transparency, and it's traceability, because since the ledger is immutable, then you know exactly who does what when. So you have a full traceability of what happens. Then, blockchain is very rooted on security. I don't want to enter in the Bitcoin history, but all the blockchain platforms, they were born with the principles of Bitcoin. And Bitcoin is a cryptocurrency, and it is rooted on security in order to secure the right transaction of e-money. And then there is this other concept which is called the smart contract. This was introduced by Ethereum in 2015 for the very first time. A bit different than Bitcoin, which was the very first blockchain implementation. In smart contract, basically, you can define what is a transaction and when a transaction should be issued. Okay? So you basically can implement whatever logic you want for the transaction. And the transaction not necessarily is a cryptocurrency. It can be whatever you want. Okay? So little blockchain 101. Now, if you know those two slides, I think you know enough, at least to start speculating how you can use blockchain. And here are the cases I will show you in a while, the solutions that we have now live, okay? But before doing that, I want to show you and share with you the similarities between the ERP, connecting the departments inside one company, and blockchain, doing the same, but at another level of abstraction, right? Because here you don't have the organization in a company, but rather you have all the companies together, right? So you see the similarities, right? It's another level of abstraction. So this is what makes blockchain very appealing from an enterprise point of view. And now I will share you the use cases that we implemented. And I said at the very beginning, most of the enterprises, they are failing. But here I will show you the 3-4 use cases. 3 are already in full production with good adoption. So we have many customers using already this application, and the 4th will be live in January, February, okay? And then I will show you how we are also moving to Metaverse. So this is called Ericsson Customer Acceptance. We say in Ericsson we make antennas and network equipments. When we sell them. Hopefully we sell them, and then the customers, they have to decide where to place those antennas. They are called sites, like I guess you notice sometimes embedded in the trees or on the buildings. You see the antennas, right? So it's the customer deciding where to place the antenna and which characteristics this antenna has to have, like pointing there or pointing there with this power and so on. There are plenty of parameters to set up for the customers. When we install those network equipments, then they sign off saying, okay, Ericsson, you did a good job, and now you will get paid. But this process, before introducing this product, which is called the Ericsson Customer Acceptance, was broken. Was broken for the reasons I said before, because it was not based on blockchain, and the process was broken in silos. Why? Because they didn't trust of us, the customers didn't trust of us, we didn't trust of our customers, and then we used to run this process in a silos way, with bad efficiency all over the process, of course, and for the customers, the problem not to have the full visibility in real time what is happening with this project. Where you guys from Ericsson are placing the antenna, they had to call us or they have to send a request by email. And for us, for Ericsson, since we don't get paid, we cannot bill our customers unless they sign off the project, then we will get a delay every time on the payments. So you see the process was completely broken. But then we introduced the blockchain to bring all the parties together. So the customers, they will have full visibility in real time of what is happening with the project, where you installed it, you have the full traceability. And for us, we have the proofs, we have done the job when the customer will sign off after they validate what we say, okay? Okay, I try to explain in a few words, but this is a little video explaining the use case. Let's see if this sounds familiar to you. Okay, the audio doesn't work. Yes, but the audio doesn't work. Okay, let's give a try.
Works on a daily basis. Each network has unique requirements and technical challenges. Getting those networks validated and accepted is complex, involving multiple services, technologies, suppliers, and approval levels. Collecting the relevant proof points with speed and accuracy requires a flexible acceptance process, high level of visibility, and traceability across the entire chain. Without it, time to market gets delayed. Imagine intelligent deployment solving these challenges. Ericsson has revolutionized network deployment with a digital, agile, and modular suite of tools enabling customers to capture the benefits of intelligent deployment. Ericsson Customer Acceptance introduces a whole new approach built on blockchain technology, making acceptance swift, easy, and intuitive, like never before. How does it work? All parties involved in the process are members of the acceptance ecosystem. Information flow is streamlined and validated in real time. And at every step of the acceptance process, using digital signatures and smart contract rules, Ericsson Customer Acceptance builds bridges between all parties, providing visibility, traceability, and data integrity. It delivers a shared and agreed immutable source of truth. Built with users in mind, Ericsson Customer Acceptance brings meaningful and intuitive functionality with immediate benefits. Through this collaborative ecosystem, Ericsson makes it possible to overcome traditional acceptance barriers.
Okay, so this is a real product, and we have tens of customers already using this, and this is fully based on blockchain. I have a few others that I want to show you. Another one which is also in full production is the letter of credit, which is another very well-known finance use case where there is no trust between the parties. So our customers, they don't trust of us, we don't trust of our customers, and even the banks in between, they don't trust each other. It happens in some weird countries, right? And again, matter of trust. And here blockchain can play the big role. So this process is very cumbersome, still using fax, is, if you know this technology, very old, stylish, maybe the young generation, they do not know, but it's a very old-fashioned technology, printing papers and so on. So we digitalized this process, and since the parties here, they can trust each other, then we managed to digitalize this flow. I have also another video, but I have to skip for matters for sake of time. This is another use case we are implementing right now and will be live January, February next year. It's basically the traceability of the hardware. Someone mentioned in the previous panel the traceability of the hardware. When we deliver and we ship the hardware to our customers, we lose control. Rather, if we have a common platform, then when the hardware is returned because of any failure, then we know what happens and we can keep trace when we send it to the factories to adjust and repair the hardware. So this is also another one, but I want to pitch very few minutes on other things that Ericsson does in order to facilitate the metaverse, right? So let me pitch very quickly. You are familiar with the 5G network, right? One of the main benefits of 5G is latency. Latency is 1 millisecond, meaning the response you get it's extremely fast. And this is a gaming event where you guys, when you play with your phone, you don't want lags, right? You want immediately react. Okay, thanks to Ericsson, if you have no latency there, because we are the ones, together with the other few, but providing the connectivity that you don't see, of course, but the connectivity is extremely important, right? So if you don't have delay in your user experience playing, it's because the connectivity is good. And 5G is the one securing on the mobile network such ridiculous latency. Another thing is 5G enables the Internet of Things, which also means consoles, it means self-driving cars, and so on and so forth. In a way, to have 1 million IoT devices in a kilometer square. It's a lot, right? So if tomorrow we can go IoT Big Bang, it's because 5G will enable IoT devices, okay? And also the transfer rate. The transfer rate in 5G is up to 20 gigabytes per second. It means you can download a full movie in just a few seconds, right? So all those things is because of the connectivity that you don't see, but you experience indirectly, right? What is the problem of this? The problem is, okay, we enable the IoT ecosystem. There are projections saying in 2025, we will have 100 billion connected device. And this architecture, despite spectacular, but is still very centralized. So with the 100 billion devices, it will be extremely difficult even for 5G to enable such kind of booming of IoT. So where blockchain can play a good role is actually to build up another layer to enable the peer-to-peer connection so that you don't need the centralization of the network. So this is called the layer 2 of the architecture, right? And I want to finish introducing very few stuff, and here it's very related to what the main topic of this event, right? So this is what we have done with the NTNT. You know, it's the super big mobile operator in US, together with the Warner Bros, Qualcomm, DreamSpace, NVIDIA, and virtual reality. Together, we made a virtual reality Harry Potter environment. And I show you the very last video. I will skip this, it's quite boring, but the point is you can have really a smooth experience when you use these devices only if you use basically 5G. Otherwise, did you see here around, despite a very nice and appealing experience, the guys with the backpack, but you need to have a backpack. Yeah, okay. Already the device itself, it's quite cumbersome. But with 5G, you enable all those devices to have quality, to have users, and to have a great experience. My last one, it's this video showing this experience with AT&T, and I have done.
Visitors to New York City's sprawling new Harry Potter store can immerse themselves in a world of magic. One of the big attractions, a virtual reality experience called Chaos at Hogwarts.
The experience, once you put that headset on, is unlike anything you've ever seen. You really feel like you're in the castle.
Fire over here. It's quite realistic. I got to check it out a bit closer to home on a Hollywood area soundstage where it was created. AT&T using the virtual reality adventure to showcase the potential of 5G technology.
We're showcasing future technologies that really give a glimpse to the ecosystem of where things are going. Lighter weight, faster processing, better experience.
In the story, you miss a train and cast spells. Unlike typical VR setups that require a backpack computer, this one uses 5G to allow the processing to happen in the cloud. All you need is a lightweight headset.
Wi-Fi is not capable of doing that. Doesn't have the performance, doesn't have the low lag.
AT&T set up special 5G antennas for the demo.
The sensors are going back and forth with the content to the headset over 300 times a second.
Less lag means less motion sickness. I mean, it does feel like you're experiencing an entirely different world. And only when you take this off do you realize you're on a soundstage. YouTuber Joshua Vergara was also in my group.
This is just a whole new way of not only doing storytelling, but of experiencing content.
Tech pushing the future of entertainment forward.
Okay, that was all. I
Thank
I
you.
finish here, right? But I think now you understand where Ericsson plays a role even where nobody knew before, right?
I feel like I really need to thank Ericsson for having all the backbone of the technology that we use every day. And as a Harry
And
Potter,
nobody knows, actually.
yeah, and as a
right?
Harry Potter fan, I want to try this. Don't you guys want to try this out?
Now you
Great.
know. Now
Yeah.
you know.
Thank you very much. Yeah, we're going to
Absolutely
set up for
pleasure.
our next panel immediately. And thank you, Giovanni.
Thank you, guys. Thank you.